Objective 3, compute the sum of squared residuals. Recall that the least squares regression line minimizes the sum of the squared residuals. This means that the sum of the squared residuals is smaller for the least squares line than for any other line that may describe the relation between the two variables. So in particular, the sum of the squared residuals is smaller for the least squares regression line in example 3 than for the line obtained in example 1. It is worthwhile to verify this result. So for this next example, we're going to keep computing the sum of squared residuals. We're going to compare the sum of squared residuals for the linear models in example 1 and 3. We're going to use a table to compute the sum of the residuals squared using the predicted values of y hat for the equations in examples 1 and 3. Now, when we look at this table, table 6 is going to contain the value of the explanatory variable in column 1. So there is column 1, which is the club head speed. This is the explanatory variable. Now, that's column 1. Now, if we take a look at column 2, it's going to represent the response variable, which is the distance. And so here is our two columns. Now in column 3, it's going to contain the predicted values using the equation that's found in example 1. So what that means here is this is our equation that we have in example 1. It's y hat, which is equal to 2.8333x minus 22.4967. This is the equation that we got from example 1. And what we're going to do is we're going to figure out the predicted values using the values of x for each particular one. So let's go ahead and do that. So we're going to go ahead and substitute. So we got 100 represents our value for x. So to find the predicted value, we take 2.8333 times 100 minus 22.4967, and then that gives us a predicted value of 260.8. The next value for x is 102. We're going to plug 102 in for x into the equation. 2.8333 times 102 minus 22.4967 is going to give us a predicted value of 266.5. Next, we're using the value of x, which is 103. And we're going to plug that into our equation here. So 2.8333 times 103 minus the y-intercept gives us 269.3 as a predicted value. Next, we're going to substitute 101 into the equation. So now 101 is now the value of x. Plug it into the equation, and we get a predicted value of 263.7. The next value of x is 105. We're going to plug it into our equation, the same equation, evaluate the equation, and then give us our predicted value of 275. Next value for x is 100. Plugging that into our equation and evaluating the equation gives us a predicted value of 260.8. Next, we have a value of 99 for x. Plugging that into our equation, evaluating it gives us 258.0. And then the last value of x is 105. Plugging that into our equation and evaluating that gives us 275. So remember that in this column, this is representing the predicted value. So this is the predicted value, meaning the predicted y value. And then if we look to the left, the distance, well, this represents the observed y value, meaning that this is the value that was given. This is the observed y value. So now we're going to take these observed values and then subtract the predicted value. So we're taking our observed y value and then subtracting the predicted value. So let's take a look here. So we have our observed, which is 257, and then we're subtracting our predicted value to get negative 0.38. And that is the residual for the first one. Okay, the next one, we're going to take the observed y value, which is 264, and we're going to subtract the predicted value of 266.5, which gives us a residual of negative 2.5. Next, the observed y value is 274, and we're subtracting the predicted value of 269.3 to give us a residual of positive 4.7. Next, the observed y value is 266. We're going to subtract the predicted value of 263.7 to give us 2.3 as a residual. Next, we take 277 as the observed y value. We're going to subtract the predicted value of 275.0 to give us a residual of positive 2.0. Next, we take our observed y value of 263, and then we're going to subtract the predicted value of 260.8 to give us a residual of 2.2. Next, observed y value is 258, and then we're going to subtract the residual of 258, which gives us, predicted value of 258, which gives us a residual of 0.0. And then our observed value of 275, we're going to subtract the predicted value of 275, which gives us a residual of 0. Okay, now we're going to take these residuals and then we're going to square them. So what we're going to do is we're going to take negative 3.8, square it, and that gives us a value of 14.44. Next, we're going to take the residual of negative 2.5 and square it to get 6.25. Next, we're going to take the residual of 4.7 and square it, and then that's going to give us 22.09. Next, we're going to take the residual of 2.3 and square it, and that gives us 5.29. Next, we take the residual of 2.0 and square it to give us 4.00. Next, the residual of 2.2 squared is going to give us 4.84. The residual of 0 squared is going to give us 0. And the residual again of 0 squared is going to give us 0. Okay? Now, what we need to do is we need to find the sum of this column. So we're going to add up all of these values. And down here, the sum of the residuals squared here is going to be 56.91 for this example one. Okay? Now, we're going to look at the new equation, which is example 3 equation. And here's the equation. Y hat is equal to 3.1661x minus 55.7966. So we're going to do the same thing in this equation. So now we're going to take the value of x again, okay, and we're going to plug them into this equation now. It's a new equation. We plug it into the equation. It's now going to give us a predicted value for example 3. So again, this is going to represent the predicted value for example 3. And again, recall that we substitute that into our equation and then get the predicted value. So we have 260.8. We plug in x into the equation, 3.1661 times 102 minus 55.7966 to give us a predicted value of 267.1. We plug in another value of 103 into that equation for example 3 to get a residual of 270.3. Again, plug in the same value of 101, and we're getting that from our first column here. Plugging that into the equation gives us 264 for the predicted value. Next, we plug in 105 for the value of x to get a predicted value of 276.6. Next, we plug in the value of x, which is 100, into that equation to give us a predicted value of 260.8. Next, we're plugging in the value of x to be 99 to give us a predicted value of 257.6. Next, we plug in the value of x, which is 105, to give us a predicted value of 276. So just as we done here before, we're now going to then do the same thing in this space here. So in order to find the residual, okay, we need to take the observed value and subtract the predicted value. So recall that the observed value is in the second column, which is 257, and then we're subtracting the predicted value of example 3 to give us a residual of negative 3.8. Similarly, we're going to take the observed value, y value of 264, subtract the predicted value of equation 3, 267.1, to get a residual of negative 3.1. Next, we're taking the observed y value of 274, subtract the predicted value of equation 3 of 270.3 to give us a residual of 3.7. Again, we're taking the observed y value of 266, subtracting the predicted value of equation 3 of 264 to give us a residual of 2.0. Again, the observed value of 277 minus the predicted value of equation 3 of 276.6 to give us a residual of 0.4. Next, we're taking the observed y value of 263, subtracting the predicted value of equation 3 at 260.8 to give us a residual of 2.2. Next, we're taking the y value of 258, which is the observed y value, subtracting the predicted y value of equation 3 at 257.6 to give us a residual of 0.4. Then last, we're taking the observed y value of 275, subtracting the predicted value of equation 3, which is 276.6, to give us a residual of negative 1.6. Okay? And so now we're going to do what we did before. We're going to take the residual, which is negative 3.8, and square it, and then it's going to give us 14.44. Next, we're going to take the residual of negative 3.1 and square it to give us 9.61. The other residual is 3.7 squared to give us 13.69. The residual of 2.0 squared is going to give us 4.0. The residual of 0.4 squared gives us 0.16. The residual of 2.2 squared gives us 4.84. And then the residual of 2.2 squared is going to give us a value of, that should be 0.4. So let me make sure to change that there. That should be 0.4. I want to make sure that I change that value so you can see that. So this should be 0.4 here. Okay, so 0.4 squared gives us 0.16 as our squared residual. And then the last one, negative 1.6 squared, is going to give us 2.56. So now when we total up this last column, we're going to get the sum of the residuals squared to be 49.46. So we're going to compare the sum of the residuals with example 1 equation and example 3 equation. So the sum of the squared residuals for the linear model in example 1 over here is 56.91. The sum of the squared residuals for the least squares regression linear model over to our right here is 49.346. Again, any line other than the least squares regression line will have a sum of squared residuals that is greater than 49.46. So now the figure below shows the regression by eye-applet with the least squares regression line in red. So the least squares regression line was the one that we found in example 3. Okay, so recall that the line here in red represents the one we found in example 3, and that is y hat, which is equal to 3.1661x minus 55.7966. Okay, and then example 1 represented the line that we had as y hat, which is equal to 2.8333x minus 22.4967. So look at the bottom down here. If we take a look, okay, so here is the green, the first line, which is that line right there. Okay, we could also see that the y-intercept is negative 22.468, and we can see that the slope is 2.834, rounded just a little bit. Okay, and if we take a look at the regression line, which is the one in red, we can see that the slope down here, or the y-intercept, excuse me, is negative 55.797, and the slope is 3.166. Now again, now it's showing that the least squares regression line, which is red, along with the line similar to found in example 1 here. Now notice that the total area of the green squares, okay, which is 55.72928, okay, is slightly larger than that of the red squares, which is 49.857628. Again, no line will have a smaller sum of squared residuals than the least squares regression line.